Hi everyone, welcome to RoshChem summary videos. In this video, I'm showing you some calculations involved in equilibrium constant. Okay, so look at the reaction given here. So it's N2 plus 3H2 is given NH3. So we'll first see how to write the equilibrium constant, the expression for the equilibrium constant, which is called Kse expression. So when you write the Kse expression, so on top you need to have the product, which is NH3. The square bracket represent here the concentration. So it is the concentration of NH3 power 2. So power 2 comes from the coefficient. The coefficient in your balanced equation becomes power. So it's Kc equals to then NH3, which is the product, power 2 divided by the concentration of N2, which are the reactants. Concentration of N2, so you don't have a coefficient, so therefore it's just power 1, we don't write it, times the concentration of H2 power 3, because the coefficient of H2 is 3. So this is how we write the Kc expression. So in your expression, you need to have the products on top divided by the reactants, and there the concentration, the square bracket represent the concentration here, the coefficients become the power. And what is the unit of Kc? The unit of Kc will change from equation to equation. So now in this equation, the unit of Kc is m to the power negative 2. So how do we get it? So we know all these terms are concentrations. So NH3 concentration power 2. Okay, the unit for concentration is molar. So I write m to the power 2, molar power 2. Then divided by N2 concentration is just m times by H2 concentration, m to the power 3. Okay, so which means the top is m to the power 2 divided by m into m to the power 3, which means m to the power 4. So when you simplify, you will get m to the power negative 2. So like this, the unit of Kc will vary from equation to equation. Okay, we will now see some calculations involving equilibrium constant. Okay, look at the first question here. A2 and B2 were mixed in a 2-liter vessel, closed vessel. Once the reaction reached the equilibrium, it was found to contain 2.1 mole of A2, 3.4 moles of B2, and 1 mole of AB at 500 degrees Celsius. What is the value of equilibrium constant at the same temperature? So why the temperature has mentioned here? Because we know the equilibrium constant is varying with the temperature. The first thing to look at is whether the given amounts are at equilibrium or not. Now in this question, it says once the reaction reached equilibrium, it was found to contain, which means all these amounts, so 2.1 mole of A2 and 3.4 moles of B2 and 1 mole of AB, all are at equilibrium. So because in my Kse expression, like Kc equals to once the reaction reach the equilibrium. So all the concentrations must be at equilibrium therefore. Right, so what I first do, I look at the equation and you write the Kc expression. So which is AB squared, because you have 2AB, so that becomes AB squared, divided by A2 into B2. So now you need the concentration. So how do I find the concentration? So we know that C equals to N over V. Concentration equals to moles over the volume. So the moles are given, therefore you divide by the volume, which is 2 liters, to find the concentration. That's what I have done here. So AB moles is 1 mole, so I divided by 2 to make it to concentration, so which is molar now. So power 2 and divided by A2. A2 moles is 2.1, so you divide by 2 to make it concentration, and then B2 moles is 3.4, you divide by 2, so to make it concentration. So after that I got the answer 0.14. Now in this case you will see there's no unit for the Kc value. The reason is you can see in your Kc expression you have AB squared, so which means the concentration squared, so which is m to the power 2 divided by AB concentration, which is m. B2 concentration also no power, so it's just 1 m. So then m to the power 2 divided by m to the power 2, so no unit, so they get cancelled. So that's why in this case there's no unit. Okay, now we'll look at another question. So in this question, you need to find the concentration. The K value is given. So an equilibrium mixture contains 1.2 moles of A2 and 1.8 moles of AB at 200 degrees in a 2-liter vessel. What is the concentration of B2 at equilibrium? Right. So Kc value is now given in this question. So you can see the temperature is 200. The Kc value was also found at 200 degrees. And so you are given the moles of A2 and also you are given the moles of AB. So it's asking for the moles of B2. It's asking for the concentration of B2. So what I do, write the Kse expression. So now you can see this is the Kc value. So that is equals to AB squared. So write the expression now, AB squared divided by A2 into B2. So now substitute what you have. So AB squared, AB is AB squared. So you have AB's moles given. So you have 1.2 moles of A2 and 1.8 moles of AB. So AB's moles is 1.8. You divide by 2 to make it concentration. So that's why I got 1.2 divided by 2 squared. So that's AB squared. That's the concentration. Into divided by then A2. A2's concentration is 1.2 divided by 2 because 1.2 is the moles. You divide by 2. We don't know B2. So just leave B2. So you can see you only have one unknown term. So then when you simplify this equation, so B2 is equals to then AB squared divided by A2 divided by the equilibrium constant. So therefore you get now 6.14 molar. Molar is the unit for the concentration. Okay, we look at the third calculation now. Okay, so in this calculation, we need to apply stoichiometry to find the K value. Okay, we'll read the question first. Equilibrium was achieved between A2, B2 and AB at 300 degrees according to the following equation. So same reaction given. 0.48 moles of A2 and 0.52 moles of B2 was placed in 2-liter vessel and allowed to react. It was found that 0.24 moles of AB was present at equilibrium. Calculate the equilibrium constant at 300 degrees. So why this question is different? In this question, the given moles of A2 and B2 are not at equilibrium. So you can say, it says 0.48 moles of A2 and 0.52 moles of B2 was placed in 2-liter vessel. So that's not the equilibrium amounts of A2 and B2. That's how much you added at the beginning. So when you have this kind of a question, so when the initial amounts are given, not the equilibrium amounts, I make the ice table. So this is how you make the ice table. First write the given reaction with the coefficients. And then after that you write ICE. So ICE stand for initial, I stand for initial, C is for change, and E is for equilibrium. Okay, now put the values given. Right, so you have 0.48 moles of A2, so that's why I wrote 0.48 moles of A2 here. That's the initial amount. And B2 is 0.52, so I wrote 0.52 there. I didn't place any AB, therefore I write 0 for AB. Okay, now it says it was found that 0.24 moles of AB was present at equilibrium. Now, AB amount is given at equilibrium. For AB, 0.24, that is at equilibrium. Therefore, for AB, you write 0.24. That's the amount at equilibrium. So in front of the equilibrium, so for that row, you should write 0.24. That's the amount of AB at equilibrium. Now you need to complete rest of the table. So what information I have to start the calculation? I have the initial moles of A2, initial moles of B2, and also I got how many moles of AB present at equilibrium. Okay, so now we will see how to complete the rest of the table. So you start with 0 moles of AB. So if you have 0.24 moles of AB at equilibrium, which means your reaction has produced how much? 0.24 moles of AB. So I'll repeat that. So I started with 0 moles of AB. Now once the reaction reaches the equilibrium, you have 0.24 moles of AB, which means your reaction has produced 0.24 moles of AB. So that's why I wrote plus. So plus indicates the produced. Okay, then if AB was produced, A2 and B2 will react. So that's why I have written minus here to show they were reacted. So how much of A2 and B2 react? For this change row, use the stoichiometry. So look at the coefficient. So it's A2 is 1, B2 is 1, and AB is 2. So 1 to 1 to 2 is the ratio. So if you know how many moles of AB produced, the moles of B2 reacted will be 0.24 divided by 2. Why? Because it's 1 to 2 is the ratio. So for this row, we are using the molar ratios. And also if you know how much of AB produced, which is 0.24, so how much of A2 will react then? It's again half of that because it's 1 to 2 ratio with AB. So now you got then, so now we can complete the equilibrium row. So which is now you started with 0.48 moles of A2. Then how much reacted? 0.24 divided by 2, which means 0.12 reacted. So how much left then? 0.36 moles of A2 left. And then B2, I started with 0.52. So this much reacted. 0.24 divided by 2, so 0.12 reacted. So how much left then? 0.52 minus 0.12 left. Okay, now you have all the moles of the three chemicals at equilibrium. So now you can find the K value. So I write the K expression, which is AB squared divided by A2 into B2, right? And remember, so in your Kse expression, these are the concentrations. Therefore, you should convert the moles into the concentrations. So AB's mole is 0.24. I divided by 2 because to make it to concentration. So power 2. And then A2 is 0.36 divided by 2. Right? That is to make to the concentration. And B2's mole is 0.4. You divide by 2. And then you get Kc as 0.4. So that's how you use the ice table when the equilibrium moles are not given. Okay, so now we have discussed the three main types of calculations involving equilibrium constant. Now it's time to do questions. There are many questions in my study guide. So you can find the summary notes and questions on pages 70 to 81. So you can visit our website www.roshchem.com if you want to find out any more details. I will see you in another video. Thank you.